But we're going to leave that there for now. We're going to talk about medians and altitudes of triangles. Y'all written this down, you know what I'm talking about, right? Okay. No, don't quite know what we're talking about, but we're about to. All right, here we go. Median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. You need to write down all of this and all of this. Don't worry so much about the diagram just yet, okay? Every triangle has three medians. The medians are concurrent. Okay? Medians are concurrent. They're going to intersect each other. They're going to happen at the same time. Really? Yeah, they do. Well, they should be more curves. You got way more curves, right? Think about that. Those things there. All right, you need to write this down, the centroid theorem. Okay? The centroid theorem. First off, let's write this definition. The point of concurrency of the medians of a triangle is the centroid of the triangle. Once you get done with that, write down our centroid theorem. Okay? Right. The centroid is always inside the triangle. The centroid is also called the center of gravity. It is the point where a triangular region will balance. The centroid theorem says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Really strange to begin with. Okay? But it's true. 2/3 of the distance. They might not be good, but they have parts. Okay, you know, I really like that. All right, check this out, guys. So check out what's happening here. Notice AY. Okay, this is kind of tricky if you can't visualize it. Y is the midpoint between B and C. Everybody good with that? Okay. Y is the midpoint between B and C. That means that it cuts it into two congruent segments. BY and CY are congruent. When I draw my median line all the way across here, right? That median line, AY, okay? The distance from A to P is 2/3 the distance from A to Y. Distance from A to P is 2/3 the distance from A to Y. So if A to Y is 3, A to B is 2. B to Y would be 1. Okay. Same thing for these other medians. Where these three medians intersect is called the centroid. Okay. Watch it in action here. This would be an example of what you might see on a test. Okay. In triangle LNN, let's see how we do this. R to L is 21. Don't worry about it. Okay. R to L is 21. Find L to S. Well, if the entire distance is 21, 2/3 of that distance is 14. Okay. This is 1 7. 7 times 2 is 14. All right. So really, you just need to remember to multiply things by 2/3, and you'll be okay. Okay. All right. What about N to Q? Remember, we said SQ is 4, right? We said this was 4, so what's the entire length? Look how we do this. N to S is 2/3 of the distance into Q. We don't know how far, right? I don't know how far N to S is, and I don't know how far N to Q is. Okay, but I do know this. I do know that 2/3 of N to Q plus S to Q is N to Q. 2/3 of this distance, 2/3 of N to Q plus whatever's remaining over equals the entire distance from N to Q. 2/3 NQ plus SQ equals the entire distance NQ. Okay, of that, I have this part right here. I have S to Q, right? I have that part right here. I've got 2/3 NQ plus 4 equals NQ. That's what they do here. Okay. If I subtract 1/3, this would be if you subtract 2/3 NQ from both sides. Okay. Subtract 2/3 into Q from both sides. If I'm talking in terms of fractions, and my denominator is 3, and I'm looking for a whole number with my numerator. 3, right? A full third would be 3/3. See that? A full third would be 3/3. That's how they get this little part right here. Okay? 1/3 NQ, 4 equals 1/3 NQ. I can divide both sides. Or you can divide both sides by 1/3 or multiply by the reciprocal 3/1. And that's how you get 12. Right? I think y'all can tell just by that, that's the toughest problem. Okay? That's the toughest thing I can ask you in this situation. Right? Just write this down, please. I'm not gonna worry too much about this. Altitude of a triangle, a perpendicular segment from the vertex to the line containing the opposite side. And please write down my helpful hint right here. Okay. That helpful hint, the height of a triangle is the length of the altitude. All right, let's write this down. The point of concurrency, and then you can put of the altitudes, is the orthocenter of the triangle. Okay, the point of concurrency of the altitudes is called the orthocenter of the triangle. In case you ever asked, we did the definition of an orthocenter. Okay, let's write this one down. We're kind of shifting gears now, okay? So we did medians, altitudes. This is a mid-segment. A mid-segment of a triangle is a segment that joins the midpoints of two sides of the triangle. The midpoints of two sides of the triangle. Every triangle has 3 mid-segments, which form what we call the mid-segment triangle. Okay. Notice that it's a little bit different than our centroid, correct? Remember, in centroid, we went from the median to the opposite angle, right? Okay. The black dots would represent our centroid. See that? Black dots, we just wrote down the medians intersect. The point of concurrency of the medians is called the centroid. Remember, 2/3 the distance. Okay. This is a little different. This is called the triangle mid-segment theorem. So a mid-segment in this example would be x to y, y to z, x to z. Okay? So if I connect median to median, That's called a midsegment. Median to median. Median to median. Those are called midsegments. And there's a cool formula that we're going to have to remember with those. No reason to sleep. No, sir. Man. I do. Again. Moving on. Okay. I'm gonna fly through this part because I'm not gonna do any coordinate points with you, but this would show you how to do it. We could start off by doing coordinate points, correct? We can find the midpoint using the midpoint formula. Okay. Once we found the midpoint formula, we could examine the slopes. Okay. If the slopes are the same, then the lines would be parallel. So what's their example here? And then we would find the height. Okay. Let me show you this example back here. Okay. Check it out. XY and PR. Let's see how those would be parallel to each other. Yes or no? Yes. They have the same slope. Okay. I'll make sure we get this. XY would be parallel to PR. XZ would be parallel to QR. Right? This way, turn this way. And then my last one, YZ, would be parallel to QP. Okay? So first thing I would do if I put this in a coordinate plane, I would find the coordinate points, P, Q, and R. Just plot the points, right? I then take my midpoint formula and find the midpoint of PQ, the midpoint of QR, the midpoint of RQ, X, Y, and Z. And then use my slope formula to check the slope, XY, and compare it to the PR. It's got to be the same slope. Same thing with XZ and QR. Same thing with YZ and QP. Finally, I could use my distance formula. Okay, comparing. Well, it says compare the heights. Okay, what you're going to use, guys, is your triangle midsegment theorem. Please write this part down. Should be the last thing that we write down. And then there's a little bit of a quiz that I'm going to give you guys to make sure you understand it, okay? My triangle midsegment theorem says a midsegment of a triangle is parallel to a side of the triangle. Its length is half the length of that side. So DE, not only is it parallel with AC, but DE is half the distance from A to C. Half the distance from A to C. This is a rather important theorem. Okay, it can help me out tremendously. DE is half of A to C. So A to C is 10, DE would be 5. 15, 7.5. 200, 100. It was called the clapper. And it was made for like old elderly people who didn't want to get out of bed. All right, let's check this out real quickly. Hey. If B to D is the midsegment of, I'm sorry, if B to D is parallel with AE, okay, and B to D represents a midsegment, BF would be parallel to C and E, and D to F would be parallel to AC. And BD is half the distance from A to E. BF is half the distance from C to E. And FD is half the distance from A to C. So if A to E is 17, B to D is half of that, which is 8.5. do this real quickly instead of you doing it on your own. We're going to do it together. E to D is the mid-segment. B to C is parallel with ED. How much is ED? 10. Half the distance from B to C. Check out AB. How this works. If FD is a mid-segment, it's parallel with BA. F to D is 7. How much is A to B? 14. Double it, right? Gotta go both ways with it. BFE. Okay. What would be true about these two angles? They'd be congruent. Okay. They would be congruent because they are similar triangles. Similar triangles have congruent corresponding